Hey everyone, welcome to Chapter 7. Now we can finally get into Python. Huzzah! The purpose of this course is to help you get comfortable with transferring your ideas into usable scripts that help speed up your workflow. I think it's good to keep things simple while you're still getting the hang of using code without getting too in-depth with certain aspects of the language or formatting guidelines. If I leave out any information in this course or loosely gloss over terms, it's because I don't want to overload you with too much information. Once you get a grasp of the basics, you can more easily expand your knowledge. In this chapter, we will primarily be looking at Maya's script editor. Also, for this course, I will demonstrate all the scripting here, though I highly recommend checking out PyCharm, which is my preferred IDE, or Integrated Development Environment. The most basic building block of Python is a variable. Variables are used to store data, and data can be categorized under different data types. For example, numbers and text are expressed with different types of data. Let's take a look. To define a variable, we assign it a name followed by an equal sign. If we execute this line, then select the variable and execute that, it will tell us what it returns. So the result here is 25. That's our value for x. Another way to return information in your script is to use print. I'm constantly adding print statements in my scripts. It's an easy way to get readable information about your code. After I run this, I can see in the history the result of x was printed. Once you create a variable, it can also be redefined. If I were to say x equals hello world in single quotes, I've changed my variable of x so that it no longer equals 25. We've also changed the type of variable that x is. Now if I were to run this, our print statement returns text. By the way, sometimes to execute my code, I press enter on my number pad. If you don't have a number pad, you can also use Control Enter. This text variable type is called a string and can be represented by single or double quotes. So if we run this, we'll get the exact same result. Comments in Python are represented by the hash mark. Let's take a look at another commonly used data type. Let's set our variable x equals to true. This is a Boolean. A Boolean is a type of data that represents two possible values, true or false, on or off, 1 or 0. That said, x equals 1 is not the same thing as x equals true, though you can use 1 or 0 to represent true or false in many Maya command arguments. For example, take the visibility on this sphere. The attribute is a Boolean. When I change its value, we can see we're setting the value to 1 or 0, on or off. If we say x equals 1, we've defined x as an integer or int value. This means that it's a whole number and cannot have a decimal. If we redefine x equals 1.0, it's a float or floating point value. The transforms on my sphere are represented by float values. You can see my channels are displaying to the nearest thousandth decimal point. If you simply go to add attribute, you can see some of the data types that I've just described. Let's add an int value. I'll start by giving it a name, and then I'll give it a min and max value. We'll go ahead and add this. If I select my attribute and middle mouse drag, we do not see any decimal values. Do not be fooled by what is returned in the script editor here. With the middle mouse drag, we can actually set this attribute to a float value. However, it will still always return an int. In the next lesson, we'll take a look at how we can do some simple math with int and float variables. Hey everyone, welcome back. In this lesson, we'll be doing some very simple math. Let's start out by defining some variables. We'll have 5 apples and 3 oranges. And our total number of fruits is equal to apples plus oranges. So if I run my code all together and then check these out individually, we have 5 plus 3 equals 8. So if we print this, we get 8. Let's take a look at another example. Let's say we're calculating the perimeter of a rectangle. So let's put each side length in its own variable. In this example, the side lengths we define are both float and int values. When we add them all together inside the variable rectangle perimeter, the resulting variable is going to be a float value, even though some of our variables are integers. What about subtraction? You guessed it, subtraction works just about as you would expect it to. Let's take a look at a multiplication example. So we have our radius and we have pi, and our circumference is 2 times pi times the radius. So what happens when we multiply them all together? We get 37.698. With division, you need to be a little bit more careful when using int values. 1 over 4 does not equal 0.25. It will round down to the nearest whole value. You'll want to make sure one of these numbers is a float value. If if you need a float value in return. So you can set 4 to equal 4.0. Now we get the value we were expecting. Here's another way you can convert an int into a float. You could say 1 over float 4 in parentheses. Now we get the same result. Likewise, if you wanted the result to be an integer, you could do something similar by saying int 4.01, and now our result is 4. Python uses a standard mathematic order of operations, or PEMDAS. And as I learned it, it's please excuse my dear Aunt Sally. So the order of operations, first you evaluate the parentheses, then the exponents. Left to right, you evaluate multiplication and division, and addition and subtraction, also left to right. So let's take a look at this equation. If we run it, we'll get the result 29.5. So how do we get there? If we do what's in the parentheses, we get 10. So I put that down here. You use two multiplication signs to represent exponents. So if I run this, 6 to the power of 2 is 36. So put that here. And then we do our division. So 5 divided by 10 is 0.5. 0.5 times 3, 1.5. 1.5 plus 6, 37.5 minus 8 is 29.5. The last thing I want to show you in this lesson is that you can change a variable by using an operator and the equal sign. So a plus equals 2 is going to add 2 to whatever our value of a is. So for example, if I run this, we have a equals 2, s equals 3, m equals 4, d equals 5.0, because we're going to divide this later. So now, if I were to run these, it's going to add 2 to a, subtract 2 from s, times 2 from m, and divide 2 from d. So we should have a plus 2 is 4, 3 minus 2 is 1, 4 times 2 is 8, and 2 and 5 divided by 2 is 2.5. So let's see if that's correct. We have 4, 1, 8, and 2.5. That's great. What happens if we were to run this again, and then we print our variables? It just did that operation again. So we can run this as many times. It's just going to keep changing our variables. That's all the math for now. In the next lesson, we'll take a look at string formatting. I'll see you there. Hey everyone, welcome back. In this lesson, we'll look at how we can handle the text data type, or strings, in Python. We briefly touched on this in the first lesson of the chapter, but now we'll take a closer look. My preferred way to concatenate strings is to simply use a plus sign. Concatenate is just a fancy way of saying to link things together. Let's take a look at this example. Let's combine these variables with a plus sign in between each one. I know that when we run this, we'll actually get an error because you cannot combine string and int values, and it will say it here. It even tells you what line number the error is in. So let's convert this to a string. All we have to do is say str and then put our variable in parentheses. If we run this by itself, it's 2, and if we run this together, it's still 2, but now our data type has been converted to a string. So when we run this all together, it works. Our returned variable, nickrigger2, is not very legible, so let's give it some padding, and maybe it will make more sense and be easier to read. So if we run this together, now we have some spacing. Let's give it some more information. We'll say, Nick is a rigger who has 2 pets. So if we run this, that's what it says. I forgot to finish my sentence, so I'll just add that on at the end. And now it says, Nick is a rigger who has 2 pets. If you find that your string is getting too long, it might be good to write this a different way. Let's take a look at Python's format function. I'm just going to replace my variables with curly brackets and keep them all inside the string. Then, at the very end, we say .format, and in parentheses, we write out our variables. Now when we run this, we get the same results as before, but when we use format, we don't need to worry about converting our numeric values into text. That's handled for us. In Python, when we count, we usually start from 0, and we'll cover this concept more in the next lesson, but this is basically saying the same thing as before. We can reorder the string by changing the numbers here. So let's put the third variable first, our first variable second, then our second variable last. And now our string will read something completely different. So now this will say, 2 is a Nick who has rigger pets. Doesn't make a lot of sense, but that's okay. You can also reuse the same variable more than once. So if we change these all to 0, it will use the first variable 3 times, and it will say, Nick is a Nick who has Nick pets. Let's try writing something that makes a little bit more sense. So we'll rearrange these again, and we'll add on to our sentence. So, and his 2 pets are also riggers. Not entirely true, but the sentence is at least coherent. If our text gets a little too long, or we just wanted to break it up a bit, we could have this print on multiple lines using -n. \n inside a string will register a new line. So when we run this all together, it will print on 2 separate lines. Another way we can write this is by using triple quotes. Triple quotes can be used to represent a multi-line string. So let's space out our text by writing 1 sentence per line. We can then surround our sentences with 3 quotes at both ends. So now if we run this all together, we get our text on 3 different lines. String objects have callable methods we can use to change the way they're written. For example, if we add .title to the end of a string, it will capitalize the first letter of each word inside of the string. We can use .upper to capitalize every letter, and we can even do some math inside this format because number of pets is still an int value. So now if we run this, the first letter of my name is capitalized, rigger is in all caps, and I now have 20 pets, which I'm sure my landlord would be totally cool with. There is a different style of string formatting that uses the % operator. This is a bit older and we won't be covering it in this course. Dot format is much more powerful anyway. However, you may come across some old code that uses this. For fun, you should try and convert it to the new style of formatting. In the next chapter, we'll take our first look at a sequence data type called list. Hey everyone, welcome to Chapter 7, Lesson 4. In this one, we'll check out how we can make lists in Python. Lists are a nice way to organize different sets of data that we either create in our scripts or find in our scene. Lists and loops are pretty much the bread and butter of automating tasks with Python. But before we can get into creating loops, we need to create something that we can loop through. So let's do that. Let's create our first list. A list is represented by brackets. Here on line 1, I'll show you my preferred way to define a list. But here on line 2, I'll give you an example of how you can use the list method. Both of these will create an empty list because we haven't put anything in them yet. I'm just going to delete this one. Let's go ahead and populate our list with some string items. Lists can contain other data types as well, but in this example, I'll use strings. In a list, each item is indexed. As I mentioned in the previous lesson, in Python, we usually count from 0. So, to print our first item in the list, we would represent that by putting 0 in between 2 brackets. And I'll just copy this line a few times and replace the index value to represent a corresponding item in our list. So if I run these all together, we can print each item individually. But watch what happens when I try to print a value that does not exist in our list. We will get an error because we're trying to access something that does not exist. To access the last item in the list, for us that's item B, we can use -1. The second to last will be -2, and so on and so forth. So if we print these individually, we go from the last to the first item. You can also return a range of items. So if we print 0:3, we'll print the first 3 items. If we were to write 1:3, we would only print the second and third item. If we wanted to print everything after the second item, that would be represented like this. And likewise, if we wanted to print anything before the second item, we could write it like this. I also want to mention that you can index a string of text the same way you would a list. So if I were to write out a string, I can then print that string. I could also print the first letter of the string. I could print the last letter of the string. And I can print the 3rd to 9th letter of the string. There are many ways you can change a list after defining it. You can directly change an indexed item by defining it as its own variable. So if we say our list2 equals joint A, our third item, which was previously item A, has now been replaced with joint A. There are also many methods associated with lists. Let's take a look at a few. I often use append, which means to add to the end of our list. So by running this, we've added item C to the end of our list here. You can also remove an index item with pop. So if I say our list.pop, and we'll put 1 as the index, it's going to remove item 2. So if we run this, we see item 2 is no longer in our returned list. There are a couple ways we can rearrange our list. I'm going to give my list more arbitrary names because it was already in alphabetical order. So if I execute this, we've just redefined our variable. Now let's use the sorted method to alphabetize our list. If I print this, our list is returned in order. However, The variable OurList has not actually changed, we just returned it in a different order. Likewise, if we run this next command, our list will be printed in reversed order, but it will not actually change the variable. The reverse method returns an object. Like many other scripting languages, data is stored in chunks of memory which can be pointed to later. I won't get too into this, I just wanted to point out that you'll need to convert the object into a list using the list method. This actually isn't even my preferred method of reversing a list. I like to write it out this way. So say print our list : -1, and this also reverses the list. To actually change your list variable, not just return something different, we can use these methods. So if I redefine, then print our list, I can see it's not in order. But if I run ourList.sort, then print our variable, we can see that our list variable has actually changed. So again, if I redefine our list back to what it was before, and I'll just print here, then I run ourList.reverse, when I print again, we can see the variable itself has changed. The last two methods I showed you are different because they do not affect our variable. These two do. One other useful method that I frequently use on lists is the length, or len method. We can use this to return how many items are in our list. While we're on the subject of lists, I need to mention what a tuple is. A tuple is like a list, but you cannot change them with any of the fancy methods I've just mentioned. And for that reason, I rarely use them. Though they're technically faster than lists, in this course, we won't be handling the large amounts of data required to notice the difference. Tuples use parentheses instead of brackets and are indexed like lists, but again, we cannot change it after it is created. It's immutable. So here I'll actually try to change one of the items in a tuple and it won't let me. If I try to sort the tuple, it won't let me do that either. In the next lesson, we'll take a look at dictionaries. Thanks for watching, and I'll see you there. Hey, welcome back. In this lesson, we'll take a quick look at dictionaries in Python. Dictionaries are similar to lists, but instead of using an index value to access your data, you use a key. Think of an actual dictionary that you would find in a bookstore. In that dictionary, the letter A is your key, and all the words that begin with that letter are your values. Of course, in Python, it doesn't need to be related to anything alphabetic, though it could. If I'm being honest, I didn't understand dictionaries right away. It took some time before I was able to use them comfortably. That said, if this doesn't click right away, do not worry. Watch this lesson once, keep it in the back of your mind, and come back to it again once you have the hang of using lists. Alright, let's create our first dictionary. Dictionaries are defined similarly to lists. You can create an empty dictionary with two braces, aka curly brackets, or by using the dict method. When you return both of these variables, you get the same results. I'm partial to the curly brackets, so I'll just go ahead and remove this one. Let's take a look at the dictionary format. We write out a new dictionary. We first have our key, and then :value. We can use the key to find our stored values. The value can be a string, an int, a list, or anything, even another dictionary. There are a few different ways we can call upon our dictionary. I'll write a few of them out here. In this example, we just have one key and one value, but later we'll be adding more. To find what is stored under a key, we can print our dictionary followed by the key name or variable in between two brackets. To return our keys or values in a list, we can use the .keys or .values method. Let's take a look at another example. Here I have 3 keys followed by a list of joints as their values. So if I define this and run it, it will return all on one line. So we see our keys and our values. If we run this line, we'll just return what's in the leg joints key. So we have a list, and that is what returns. So if we print our keys, we'll get a list of each key value in our dictionary. And same thing with the values. We'll get a list of lists because our values are all a list. So we get 3 lists. This next one might be slightly more confusing, but basically the .items method will return our dictionary as key value pairs as tuples inside of a list. This is a very useful way to unpack dictionaries and for loops, so keep this in mind for the next lesson. You can easily add items to your dictionary. You just need to define a new key for that dictionary and give it some values. So here I'm adding a new key, ear joint, to our dict, and the values inside this entry are the left and right ear joint. Let's go ahead and print this. Our dictionary will be returned on one line, so we may need to scroll over to see our new entry. So if we do that, we can see that we've successfully added ear joints into our dictionary. Our key does not need to be a string. We can use a numeric value instead. So here I'll make our key the number 42, and inside this I'll store a string value. When I print my dictionary, we can see this was added, but it wasn't inserted at the end, though I believe later versions of Python will obey insertion order. One way to return your keys alphabetically would be to use the sorted function on your dictionary. Thanks for watching, and I'll see you in the next lesson on loops. Hey again, welcome back. In this lesson, we'll take a look at while loops and for loops. I won't spend too long on while loops because I use them far less frequently, and you can very easily crash the program if you're not careful. When I started learning Python, I only knew how to use while loops. Learning for loops was a game changer for me. Most of the automation I do involves a for loop at some level. As promised, I'll show you while loops first and why I try to avoid using them. While loops will continue to run as long as a condition is true. So if I were to say x is equal to 0, while x is less than 10, let's print x and add 1 to x each time through the loop. So x increases in value until it's no longer less than 10. But let's say x is equal to 20, and we'll change the less than sign to a greater than. While x is greater than 10, which it is because we just redefined it as 20, then add 1 to x. So if we were to run this, in the next loop, x will be equal to 21. Every time through the loop, x becomes 1 greater than the time before. Thus, x will be greater than 10 infinitely. This is called an infinite loop. If I run my code, the program will crash. However, we can add some preventative measures. Let's print x after we add 1, so we know its value for each iteration. Let's also say if x is equal to 35, double equal sign means equal to, then break. If is a conditional statement, and we'll learn more about these in the next lesson. When x is a value of 35, we will break this loop. If we didn't have this, we would have to force quit the program, and that's no fun because we could lose some work. For loops, in my opinion, are much more fun. You can use them to iterate through lists, tuples, dictionaries, a number range, or even characters in a string. Let's start out by making a list. Then, we'll iterate through this list using a for loop. So for this example, I'll write a list with Maya's default joint naming. To write a for loop, we write for, then give a variable name, let's say joint, in whatever you're iterating through. So for us, that's the joint list. Then, each time through, let's print the variable joint. Now this goes through our list and prints the next joint every time. This reads, for joint in joint list, print joint. We're actually redefining the variable joint every time it goes through the list. It doesn't matter what we call this variable. We could just as easily say for x in joint list, print x. But it's good to give a name that is descriptive of what you're looping through. In this example, we're just printing a variable, but we could do so much more than that. To put code in a for loop, you just need to make sure that it is indented one level. In other words, put your code 4 spaces to the right of where your for statement is. Let's say we wanted to add a naming convention to our joints and put the newly named joints in its own list. Let's first create an empty list. Then, we'll go through our joints and append the new name into the empty list we've just created. So using the append method, I'll just add a prefix of C, and then we'll add our joint name in the middle, and then add a suffix of joint. So now if we add our print statement and run this all together, we can see our new joint list has more unique naming. Let's take this a step further and rename these to spine joints using the replace function. With replace, you write first what you want to search for, next what you want to replace with. So we'll replace joint with spine. So if I run joint, you can see our name is joint 6, and if I run this all together, now it's spine 6. So when I print my new list, you can see that we've renamed them to spine joints. Cool, this looks better, but I'm still not happy with the formatting. Let's try something else. I want to count every item in the list. To do this, we can use the enumerate method. Enumerate will return a value with every item you are iterating. To do this, we can say I, joint. Again, the variable I can be whatever you want. I just use I because it's an int value. And then we'll write enumerate in front of our list. Now we have an int value associated with each item as it goes through the loop. I mentioned in a previous lesson that you cannot concatenate strings and int values, but you can print them together if you use a comma like I did here. Now I want to give our number some padding. I also want it to start at 1 and not 0. So I can say I plus 1 and it will start at 1 and end at 6. To pad our number, we can use zfill, but to do this, we need to convert it to a string. Zfill will pad our number with zeros up to the length you specify. So if I use a value of 2, our number will become 2 digits long. So when I run this, you can see that the padding is there. To make it a little easier to read, I'll give our spine name its own variable. Then, just like before, We can sandwich this variable in between our prefix and suffix to get the new joint name. So when we run this all together, we get our nicely named joints. You know what? This is a little confusing to read. There's yet maybe a better way to do this. Let's try using string formatting. You can pad numbers by using a colon, followed by the length you want to pad with, then the letter D. This will pad our enumerated value with 3 digits. Let's add 1 to I, and also change the padding to only be 2 digits. When you run this multiple times, be sure to redefine your variable, otherwise we'll just keep adding to the list. Let's take a look at a few more examples. You can loop through a range of numbers. In this example, we'll loop through 10 integer values. If only one value is specified, it will start at 0. Otherwise, you can give it a range. Next, let's look at an example of how you can loop through a string of text. Let's say maybe we wanted to set the rotate attribute on each axis of a control or joint. When you loop through a string, each character functions as its own item in a list. Let's take a look at our dictionary from the previous lesson. If we loop through this variable, we're looping through the keys. If you remember, .items returns key value pairs. So if we add another variable and say .items at the end of our dictionary variable, we can get both the key and the value. So now when I run this, it will print the key followed by the value. We can iterate multiple lists in one loop using Python's zip function. The loop will only last as long as the list with the shortest length. Ideally, to use this function, your list should be the same lengths. I almost always zip just 2 lists together, but for this example, I'll use 3 just to show you that it's possible. So here I'm defining my lists. I'm going to give some fruit names, some colors, and some numbers, and then we'll write them all in one loop. So I define 3 variables, and then I use the zip function, and I put my list names inside of that. So now when I print F, C, and N, it will print the first item of each list together, then the second item of each list together, then the third item of each list together. In the next lesson, we'll take a look at different conditional statements we can throw into our list to make their functionality more robust. Hey everyone, welcome back. In this lesson, we'll take a look at some conditional statements that we can use to check if something is true or false. If our condition is met, then a block of code will be executed. With conditions, we'll also look at some different ways to compare values. Let's check out some examples. In this first one, I have a long list of joint names. What we want to do is organize them into separate lists. Let's first create the list we want to use. We'll want to organize these based on the joint prefix name, so all the left joints should end up in the left joint list. Let's create a loop that we can pass our combo list through. To make sure the loop is working, the first thing I like to do is throw a print. That looks good, so we can move on to the next step. What can we do if we only want to print the left joints? There are a few different ways we could do this. Most importantly, we want to ask our variable if. Then we can use the starts with method to check if our joint variable starts with L underscore. If this condition is met, then we'll print the joint name. Now we can see that only the left joints are returned. Another way to check this would be to reformat the string our variable joint returns so that we're only using the first 2 characters, then use the double equal sign, which means is equal to. So we're asking, are the first 2 characters of joint equal to L underscore? If they are, then print. I get an error here because there's no such thing as comb list. Just a little typo. It's good to note that it considers the error to be on line 1 because it is happening on the first line of code that we're executing. If I correct the name, then it all runs smoothly. For this, I'll go ahead and stick with the starts with method. Now, because I've already executed this for loop, my variable joint is defined as the last item in my combo list. Now if I run the statement, joint.starts with L underscore, false is returned, because B spring joint does not start with L. Now let's start building up the new lists. Do you remember how to append? Let's append any joint that starts with L underscore to our left joint list. Let's also throw some prints down here at the bottom so we know our lists are being built correctly. So if we run all this together, we can see that the left joint list is being built properly, but the other 3 are still empty. Let's get the other joints into their corresponding lists. To do this, we'll need to use elif, which means else if. So, if the first condition is not met, it checks the next one. You can use multiple elifs if you have more than a few conditions to check. If none of your if and elif conditions are met, and you want to do something to all the remainders, you can say else. So in this example, the remaining joints include any joint that does not start with L, R, or C. When we run this, we can see that the lists we created have now been populated. Let's take a look at an example using numbers. Let's go ahead and set our range to 25, and we'll say if x is less than 5, let's go ahead and print that. So this should print every number in our range that's less than 5. Instead of printing, we can say pass, and we'll just skip over this and not do anything. Let's add another elif condition, and this time we'll say if x is greater than or equal to 5 and x is less than 15, then we'll go ahead and print that. So x is greater than or equal to 5 and x is less than 15. So now when we print this, 5 to 14 return this statement. I'll throw in another condition, and this one will say else if x is greater than 20, we'll print x is greater than 20. Given all these conditions, I know that my remainder has to be between 15 and 20. So we'll say else print x is between 15 and 20. So now if we run all this, we get some detailed information about the numbers that are being printed. That's all the conditions for now. In the next lesson, we'll take a look at how we can write our own functions. Hey, welcome back. In this lesson, we'll take a look at functions in Python. We can use everything we've learned up until this point inside of functions. Functions are blocks of code that will only run when it's called. That means if you execute a script and your script only contains functions, those functions will be sourced or remembered for later. Calling a function is as simple as writing the function name followed by parentheses. You can also add as many arguments to a function as you'd like to make it capable of processing all the different information you want to throw at it. Let's take a look at a few examples. To create a function, you write def followed by the name you want to give the function, then parentheses, then a colon. Inside the function, you write your code. To call a function, you use the function name followed by parentheses. If we run the block of code that is our function, nothing appears to happen. However, this code has now been registered inside the program, so we can use the function name elsewhere to call upon it and run what's inside. Let's create a function that actually processes information. Maybe we'll start with some simple math. Let's have our function calculate the total length of an arm. So we'll give it two variables, shoulder to elbow and elbow to wrist. Inside our function, we can do some math. So let's add together our two variables. Let's also throw in a print, so when we call our function, we can see it print something in the script editor's history. First, I'll run our function. Then, to call it, I'll just copy the function name and arguments and paste it below. I'm also going to assign a value to each of our arguments, so we'll say 5 and 4. So now it should add these two together, and it will print out the total value, 9. You can also store the results from a function inside of a variable, but first we have to tell the function to return something. So instead of printing, let's use a return statement. Let's also create a variable called armLength to store the results of the function. Source your function. Then, when we run line 7, we get a result from our function and it is assigned to the armLength variable. If we run just the variable, we can see the results returned in our history. Keep in mind, when you use a return statement, it ends the execution of your function. So typically, if you want your function to return information, you'll want to put the return statement towards the end, because nothing after it will be executed. Let's say you wanted to pass an arbitrary number of arguments. You can do this by adding a wildcard before the argument name. In this example, we'll calculate the total length of all the given values. So start with the length of 0, then loop through all the number arguments we pass. Each time, we add the value to our total length variable. Then we'll return that variable. You would get an error if you try to access the total length variable outside of the function. Unless you're using classes, which we'll look at in the next lesson, variables defined in a function stay inside that function. To use them elsewhere, you'll need to redefine them. So now, outside of the calculate length function, I've defined the total length by passing number values as arguments through my function. Let's take this function further and give some more arguments so we can tell it to either calculate the total sum, the mean, or both. To find the mean or average, we take the total length and divide it by however many values we're adding together. So make sure it's a float, then we can use len to find out how many numbers we're passing into the function. Next, let's add conditions for our 4 possible combinations. We can say if sum and mean, which checks if they're both true, then return them together as a list. Next, we can check the sum. If it's true, then return just the sum. We can do something similar for the mean. So if the mean is true, just return mean. The only other option that's left is that they're both false, but we can just say else. Let's throw an error if both the sum and mean are false. That way the user has to use one or both. This way we know something will be returned. To give an error, we say raise runtime error, then inside we'll give it a message we want to display when the condition is met. Let's also remove the last return because we don't need it anymore. Now let's try to use this function to define different variables. By default, our sum and mean arguments are set to false because of how we define them in our function. Order here matters, so let's set the first argument for sum to true, then the second for mean to false. We can see the total sum of 15 was returned when executing the sum variable. Let's do the same thing for mean, except for this time we'll set the second variable to true and the first one to false. Now when we run this, our mean is returned. Now let's create a variable that returns both the sum and mean. Remember, we returned a list in this condition, so if we print this variable by itself, we see the list. To separate them, we need to give the variable an index value. Now we can print them each on their own line. There's another cool way you can define these together. If you have more than one variable return, you can actually define more than one variable at a time. So I'll go ahead and define sum and mean by running this function. The return values are assigned in order. And for the last condition, when neither sum or mean is true, we'll get that error message that we wrote. So let's set these both to false and then we go ahead and run, and we can see that we must set one of these to true. This is a slightly more advanced concept, but while we're on the subject of functions, let's talk a little bit about lambda functions. I'm showing you these not to confuse you, but because we will come back and use lambda when we go to write our GUI, or graphical user interface, in the last chapter. So just keep this in the back of your mind for now. Lambda is kind of like a mini function. You have an argument or arguments, then an expression. So in this example, I'm using lambda to add 4 to whatever value I input. It's just like using function notation or f of x in math. In the next example, we use two arguments. Let's say x and y. In the expression, we'll just add them together. This is just like what we did for calculating the arm length in the previous example, except this time we're using lambda to do it. Now when we run our variable, the x and y input should be added together, and that result is returned. In the next lesson, we'll take a quick look at how we can use the same variable across multiple different functions by using classes. Thanks for watching, and I'll see you then. Hey everyone, welcome back. In this lesson, we're going to take a quick look at classes. I'll give a brief overview for now, but in attempts to keep things simple, I'd rather have you focus on the principles we covered in the previous lessons. The concept of classes in object-oriented programming did not come easily to me at first, so don't be discouraged if this doesn't click right away. My lesson on functions was only 6.5 minutes. It will take longer than that to get comfortable using them. After you have a firm grasp on functions, then I encourage you to take your coding skills to the next level and start using classes. In Python, an object contains data and code. You can use classes to create an instance of an object. These objects are reusable bits of code that contain different attributes or properties and are capable of handling multiple functions. They're modular, so we can use them in many different ways. We can even combine or inherit properties between classes. And because we create instances of an object, we can have several instances on the playing field at once. This is the core concept of object-oriented programming. To demonstrate classes, I made a watered-down version of one of my favorite classics. I'm going to review it with you over on screen left in PyCharm, just because the syntax highlighting is a little bit easier to read than Maya's. But we'll go ahead and play it in Maya. Air quotes around the word play. In line 1, we define our class. This first function is called the init function, and we use it to initialize attributes within this class. So for us, we have a character with abilities, coins, life, and HP. We can spawn a character, so to speak, or create an object by executing our class inside a variable. When we do this, we create an instance of our object with a specific set of attributes. The next thing I want to talk about is this self you see everywhere. By using self, we can access any other instance we define inside of our class, as long as it uses the self keyword. This means we can define a variable in one function and use it in another. For example, in our init function, we're defining all sorts of attributes for our character. Throughout the game, other functions of our class will be modifying these attributes. Let's take a look at the next function. We can use this power-up function to provide our character with some special abilities. I've added a few conditions for when we add a power-up. You get an error if you try to add an ability that doesn't exist. If our character eats a mushroom and already has 3 HP, nothing happens, we do a pass. If you eat a mushroom and have less than 3 HP, we still have no ability, but we make sure our HP is set to 2. If you get fire, we set the ability type and ensure HP is at 3. And if none of these conditions are met, the ability has to be a feather. So as you can see, throughout this function, we're setting our previously defined attributes. We can use this next function to give our character extra lives. I want to point out that in this script, I'm using the print function rather than the print statement that I've been demonstrating previously. Both ways work for now, but I believe in Python 3, you'll only be able to use the print function. So it may be better if we start getting used to this now. Also, if you want to use an apostrophe in your string, but can't because you're using single quotes to define the string, you can use the backslash, which also is called the escape character. Any character following the escape character will print the ordinary character. We can use this coin-up function to give our character some coins. Our first statement here says, if the value of coins we have plus what we're adding is greater than 99, then we can reset the coin counter and continue counting. But we also run the one-up function here by saying self.oneup. Here we also have some conditions that will provide us with a different message when we obtain a coin, depending on how many coins we have at that time. These next two functions we can use to take damage or kill our character. In the take damage function, when our character is left with 1 HP, we can run the kill character command. If we die on our last life, we can run the self.restart, which I've defined below, and that will basically just reset our character's attributes back to the defaults. These next two functions simply return a variable. This will make it easier to store this information as a variable outside of our class. And we can use getStatus to read back some information about our character's current standings. Let's go into Maya over here on the right. I'll scroll to the bottom of my class and highlight all of its contents, then source it by hitting execute. Once it's sourced, Maya will remember it, so I no longer need it in my editor. I'll just go ahead and remove it and clear my history as well. Let's create our characters. To do this, we can run our class inside a variable. If we define them with different character names, they'll be easier to differentiate. Now our characters are each an instant object. If we run them, you can see where they're stored in memory. Let's check in on our characters by using the getStatus function. You can use the object's variable name, the function name, to call a function that corresponds to your object. Using our character object, let's call upon the power-up function to give them each a unique ability. Then, if we get the status again, we can see that each character has a unique ability and more hit points. Let's say Mario decided to be a jerk and sell his brother's Pokemon cards for 1 coin apiece. To represent this, we can loop through a range and see Mario's coin value go up by 1 each time. Luigi is not having a good day and is hit by a Goomba. Now we can check our status again, and we can see these changes are reflected. So far, Mario is having a good day and breaks open a box with 30 coins. His wallet exceeds 100 coins, and they are automatically exchanged for an extra life. Luigi runs into a Goomba. If we check our status again, we can see Luigi is running low on hit points. Using the multiplier argument, we can give Mario 5 1-ups at a time. Luigi unfortunately takes a hit and goes below 1 and loses a life. We'll check in on our characters again. Then Mario gets a mushroom, but he already has a power-up, so nothing happens. We do pass. Then he finds yet another 1-up and gains a life. Luigi gets a mushroom, but falls up a map and loses another life. Now, because check vitals returns self.lives, we can use this function to store the number of lives each of our characters has inside of a variable. Now that we know how many lives Mario has, let's have him fight Bowser until he no longer can. When you die in this game, we hit the restart button on that character and throw an error. Now it's Luigi's turn. We can put him through a loop, but let's say, in his last life, a miracle occurs. He finds a feather, flies around, then kills Bowser. Let's get the status one last time. We can see Mario's attributes have been reset by the restart function, and Luigi has a feather and 1 life remaining. I'll include this script in the course materials section for this chapter. Play around with it and see if you can make up a scenario for 2 characters using the class's functions. In the next chapter, we'll actually start to create some useful scripts to speed up our workflow in Maya. Thanks for watching, and I'll see you in Chapter 8.